Hello everybody, this is Naveen here. I hope you have been enjoying the sessions that have been delivered so far. I hope you have been finding them useful and also exercising your R skills using some of the things that you might have learned from those sessions. So first two sessions were mainly focused on basics, and we looked at a real life data set and did some end-to-end analysis of that, typically kind of analysis that you tend to perform when you are given a data set. Today we are going to look at a stock price data. We're going to download a bunch of stock prices for different securities from Yahoo. We're going to do some analysis around that. We're going to compute returns. We're going to compute continuously compounded returns. We're going to do some date manipulations. We're going to look at reorganizing the data set in a different shape altogether, which would help us do some aggregates, and then eventually compute the aggregates, and then finally almost visualize this data set using the ggplot visualization package that R provides, which as we have discussed, can, as you already seen, provide like some powerful visualizations in R. So that's the agenda. So let's straight away dive into R. So so I'm going to create a character vector with the list of tickers. I have about 8 tickers, all the bellwethers, so as to speak, the list of symbols. I'm just going to create that. And now this is a for loop. Basically, what I'm doing here is I'm looping through every ticker, and I've chosen a start date and an end date, and I want to get like monthly, the start of month dates, right, or the month end dates for every ticker. So the compression here, like, I mean, it basically talks about a compression on a monthly basis. The object that it's going to create is a zoo object, which is nothing but like a matrix where the index of the matrix is the date. It's just kind of pretty powerful again. So this is one of those series of packages or like in tools that R provides for you to manage like the time series. We saw XTS in the last session. So similarly, time series, T series is another like package that is out there. Zoo is another package that is pretty powerful, um, even though it is not really used that much, but it's pretty powerful nonetheless. So there might be other commands to get codes from Yahoo. I'll let you guys investigate that. That's not the focus of the session. The focus of the session is more on doing analysis using the data that you pull. Yeah, so the idea is looping through all the tickers that are there in the string vector that we have, the ticker vector that we have created, and then eventually using that for further analysis. Let's go ahead and run that. I think this for loop is fairly self-explanatory. So the ticker is here. So the ticker in the list of symbols, ticker is in for it will loop through each one of these, and it will get like basically the historical price and compress it on a monthly basis, on a month-end basis, and create a data frame where every column is represented by a given ticker. Let's go ahead and run this. Okay, so it finished in no time. So obviously you need internet connectivity for you to run this command, needless to say. Um, and let us assign the column names as the list of symbols. Let's quickly investigate this data set as to what we've received. If you see here, the time, that the date is actually an index. It is not really a column of. It's not really a column of this matrix. It is actually an index. And let us study the structure of the matrix. It says it is a zoo series from whatever that date to that date. And the data is actually a matrix, which has 127 rows and 8 columns. That's what it says. So it's kind of like when useful. It's very powerful that the index is actually kind of date, and it internally organizes everything and sorts everything by date and stuff. So now let us compute the log. So if you see the formula here, you know the return is like when return is pt minus 1 divided by pt minus 1, right? So that's basically the return. So if you take like 1 on the other side, like and log both sides, basically log of 1 plus r will be the ratio of the two prices, right? um, the log 1 plus r is called the continuously compounded return. We just wanted to compute that, and this has some very nice properties in terms of in terms of distributions and stuff. And the price might itself like not be like distributed, but like the returns have like a good distribution, right? Returns can be negative, returns can be positive, and usually there'll be a good distribution of the returns. And log returns has like some very nice properties. So let's go ahead and compute the difference in the log returns. So this is log A divided by log B, which means like log A minus log B, right? So that is what it is. So the log of prices, log would mean it will compute the natural log of all prices, all the columns, and we are actually taking a difference of the log prices. That is what we are actually doing. You have seen the output of the difference command in the last session, but we'll do a quick recap of that nonetheless. So this is the log. So we applied natural logarithm to all the prices, and let's do a let's do a diff on top of that, just to see. So it actually does a diff of the log prices. So that is what it did. And the idea is we'll actually store this as continuously compounded returns. So let's go ahead and actually create a new data frame for that. The column names for this data frame, we'll call that as continuously compounded returns and append that with the relevant symbols. So if I were to run this statement, it will give you continuously compounded return MSFT, Amazon, and so on and so forth. As I said, this concatenate command is a very powerful command that you tend to use once in a while. So assigning the column names to this new so-called matrix that we have created um, will give us more information about that matrix, and let's quickly evaluate the structure of that matrix. So if you see again, it's a zoo object and it's a matrix of with dimensions 126 rows and 8 columns. So I've just assigned, just reassigning the data to another like set of variables. That is what I've done here. Um, the year and the month, just wanted to have like flexibility of slicing and dicing this data by year and month. So if you see index of all prices, as you might recall that I touched upon this earlier. So the index is not a column, right? It is like it is maintaining an index, and like index is actually the date here. So when you do an index of like a time series data set, it actually gives you the date, and like and all you're doing is you're extracting the year from those vector of dates. That is what you're doing. So here I'm just going to assign a year as well as a month to that, by actually analyzing the index. Let's go ahead and run that. Um, I'm going to do the same thing for the returns data as well. So let's look at like all prices and all continuously compounded returns again, just to see what additional fields have been added. So if you see now, you have 10 columns, 10 columns with the continuously compounded returns as well. Sorry, with the year and the month, and similarly the other matrix, the so-called zoo object, which is a matrix with like um, index of the date, also would have those additional columns. So I'm converting this so-called data, all prices. So there's this command called as core data from any time series object, like especially for the zoo object. You could use this command like core data to get like the core information. Like forget about like the data related information, but like in the core information. Let's go ahead and run that just to kind of give you a view into what like that has to offer. So let's do a head again because it's a big data set. As you see, so the as you can notice here, the indices have completely changed, right? So this actually just extracts the matrix from the zoo object, and it keeps all the relevant columns out there. So let us like look at that. Here, all I'm doing is I'm converting this matrix. Core data actually kind of results in a matrix. Let's confirm that. So if I were to do an str of this, str of the core data with all prices, actually that gives you a matrix of 1 to 127 and 10 columns, 127 rows and 10 columns. So converting that as a data frame, and then there's a slightly more advanced version of, not an advanced version, but essentially in some senses a faster version of the data frame. I'm not only going to convert that into a data frame, but also I'm going to make that into a data table. If you get a chance, you should actually look at the data table. It has some powerful features, and I'll actually demonstrate those features down below. So reassigning all prices and converting that into a data table. So let us confirm that it is actually indeed a data table now. So as you see here, it is a data table and it is now listing all the columns as well. Previously it was not listing the columns because it was considering a matrix, and that is a matrix. And in the matrix, the column names don't really matter. Like it's actually just like a name for the column, and column names are kind of not really used effectively in matrix, but like when you do assign like a name to an index, that is pretty much what you're trying to do there. It's not necessarily a column per se, right? But at least having converted this into a data table, you're able to see that all the columns are reappearing back again. Some slight nuances, nothing for us to kind of like really worry about. I'll do the same thing for like the return analysis as well. So we saw the structure of the price analysis. So let's also quickly look at this. I left this as a data frame, so we can figure out what we really want to do there. So this command called as melt command, and we'll just execute this just for fun. So here is all prices, and these are typically some of the problems that you will face as well when you're doing analysis, that you would want to convert this data set, right? So I want to almost reshape this data or like remold this data where I want like the following columns. I want like year, month, and then I want like the third column to represent the ticker and the fourth column to represent the price. You're almost kind of like narrowing the data set, is what you're trying to do, right? So this melt command is literally you're melting a data set, right? You're melting a data set into like limited set of columns. And you have to specify some pivot columns here, right? So the id.vars, you are going to specify some pivot columns. In this case, you are going to specify the year price and the year month, and we'll see what kind of output is generated from this. Let's go ahead and run this. Let's look at the top 10 rows. So the good thing about data.table is if I just like, I don't have to specify a head or whatever. Usually if I just specify the name of the data, the data table, I'll be able to get like a good output. So as you see, it will give you the top 5 and the bottom 5 records of the entire data table. Data table, just to clarify again, is a data frame. It has all the, it inherits from the data frame, but it has some powerful features over and beyond like the data frame. As I said, the data was in this format, and I had to reshape it into this format, right? So typically, you tend to do this to facilitate, like, I mean, deeper analysis of the data. So just imagine if you need to compare, if you need to get Microsoft's average, Amazon's average, this average, that average. Sometimes it's kind of tedious to write like those things. Sometimes it's easy to visualize the data like this, where you can say by year, by month, by variable. Just give me like basically the average and few other columns, right? So that's how you would want to use this data. So anyway, I've melted the data set. This is called so-called as the melting of the data set. Um, the opposite thing that you could do is you could cast the data set. You are casting, you're like, I mean, almost unmelting it or casting it to a broader data frame. So those are the two functions that are there. Very powerful. You should like explore the usefulness of that. But you just saw how I have used this, where I just had to reshape this data table into a layout which will be suitable for further analysis. So I'm calling this as the long format. I'm going to do the same thing on the return side as well. So setting the names, set names will basically set the names, just like column names or set names. It's going to set the names of the fields. I'm going to do the same thing for the returns. So now, since I have this data table, the so-called data table, we can do a bunch of things. As I said, I wanted to compute by year, basically what is the average price, what is the mean price for by year, dropping the other dimension of month and the ticker. I'm just like overall by year across all the securities. What is the overall mean, median, and some of the summary statistics. So that is what I'm doing here. If you note the command here, like the command is like the data table here. um, so this is a kind of weird syntax, but you'll get used to it. So you're like listing what all summaries you want, and then you're like almost specifying a group by column, right? Grouping by the list, the year field, and dropping the rest of the stuff. You'll get used to the syntax, but I just wanted to show you this. So that is the summary that I've computed. So, but this time I want to kind of compute the summary by year and stock. Dropping the month dimension, I'm just going to like, I mean, compare it, do this by year and stock, um, and 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 so on and so forth. This is by year and month. Um, so doing the same thing for the returns. I'm just going to execute all the three commands in one shot. Executing it again. And now you could go ahead and visualize the data. Now, what could be the possible visualizations you can look at, right? So the visualizations could be, hey, I want to look at the by year, the average price, and you're looking at you're looking at one of the data sets, one of the aggregates that you just computed here. right? You're using that to in the ggplot to compute to provide that visualization. So prices mean by year and stock is what we are actually getting. And if you see here, the Y is the average price and the color is the stock, and we are trying to group by stock. So group is a variable which will help you group the data on the chart. So if you specify group equals 1, that means it include all the data on the chart. Like, I mean, keep like, I mean, take a macro view, right? Don't really subset the data, but take a macro view. That is group equals 1. When you specify something, when you assign a variable to a group, that means you're trying to kind of organize the data set yeah, by that variable, by that stock in this case. So, and we are also here specifying that color, any color gradation needs to mimic the levels that are there in the stock, right? And how many levels do we have? We had 8 like stocks, so it'll have like 8 separate levels. Let's go ahead and run this just to see what kind of an output it generates, and then we can rationalize as to what this output is all about. As you can see, this is actually drawing a very nice time series of the price, right, of the average price for every security over yeah, average yearly price for every security for the last 10 years. And you can easily see that Amazon has the highest has actually grown the most in terms of price, and you see the levels here, and these are the groups that I was talking about. So the next graph we're going to talk about, we are again using the big data set, which is not the summarized one. The summaries are by year stock. This is the entire data set. Looking at the month, and the y-axis is the price, the color is the stock, and group is the stock. We'll just quickly run this to see what it actually has to offer us. So fundamentally it is taking month, right, like 12 months, right, for every year across months, how are the stocks actually doing in terms of the price of the stock. That is what the graph is actually communicating across all the different stocks that are there. If you were to drop the month and the year dimension, what is happening? So that's what this chart is all about. So it's a box plot. There's like a lot of variability in the Amazon stock. It seems to have gone up a lot. So compared to so there seems to be it seems to be pretty volatile, but at the same time, on an average, it has generated higher returns. And if you see GS, Goldman Sachs, it's a less volatile stock. You can see that by the distribution itself, and it has like really maintained its consistency. And some of the other bellwethers show very little deviation compared to Amazon. The challenge is looking at the price chart is it's not normalized. So Amazon is kind of skewing the distribution because it is actually priced on an average about 150 to 350, and rest of the stocks are really on the lower side. That's why typically you tend to use like returns and log returns or ratios, which will help you do a comparative analysis. So this is the box plot we just ran. Consider the Amazon stock and draw a regression line. I'm just going to subset the data. Stock is equal to Amazon. I'm just going to draw a regression line and just to show you how it looks. So this is the Amazon stock on a year-by-year basis. So for every year, looks like it has had a stellar year every year. Um, uh, so here, let's kind of quickly do another chart where we'll basically remove that scales equals free scales equals free y, and see how the chart actually looks like. And this will help you do a comparative analysis where it'll keep the this one the same. As you see, this is all, you don't really see too much variation here, but and it is using the same scale for all the panels, if you can see here. The challenge is like some of these smaller ones, and you can make a statement saying the price was like really low in all these years, 2005 to 2008, and it seems to be steadily growing from 2009 to 2015, and like it really kind of shot up tremendously from 2013, right? 2013, from almost like in 200 levels to 215 levels. So that is the beauty of this letting the scales for the y-axis um, be flexible. So we did that. We did some interesting visualizations there. So let us see how basically the continuously compounded returns across all stocks are doing, just so that we get like a view into that as well. Let's go ahead and run that. So here again, looking at the return analysis, year price, and then return, and doing a box plot across all the years. Just doing a box plot of that. Yeah, so returns, like I mean, returns are in the range of few things are positive. 2008 in general was a negative year. You can make that out. Even the bellwethers are down. Um, but more or less, like I mean, the returns are like I mean, yeah, pretty fine, nicely divided uh, on the positive as well as on the negative side. If you were to draw curves, right, like I mean, obviously you are likely to see a normal distribution there to some extent. Let's run this chart to see what it has to offer. So this is on top of the box plot. We are trying to identify how the average is doing compared to this. As you see, the average is like pretty much hovering near the median in most of the cases, and that is the observation that you can make. And if you want, you can actually connect that up with like a line chart. That is what we are doing here. So I was explaining to you about some of the aesthetics that you would like to set, and group equals one is it is actually looking at like all the data set within the group. Um, it takes a macro view. It doesn't really like try to group by a particular thing. For example, in this case, it is grouped by year, but what we are like asking it to do is ignore the group and look at all the data set. That is what we're trying to tell it. It actually draws the point, and it actually draws the line as well on top of that. So and then obviously we are providing all the nice x-axis titles and stuff. Now let us run this and see what it has to offer. Okay, so this is every year, almost like looking at, is there some kind of a seasonality in every month across all the years? Is there some kind of like a trend that you can see? Not necessarily a useful chart, but like a useful way to kind of like look at the distribution. It's hard to kind of visualize, hard to see trends uh, across years for a given month. Mm, I don't know what necessarily it has to offer, but an interesting view. So all you can conclude from this chart is there is no real positive correlation or any conclusions that you can draw from this. In some years it seems to be volatile, in some years it seems to be less volatile, and there's no real pattern that you could draw from here. But an interesting chart. So this is like a scatter plot of sorts, which is month and year, and you are able to the size of the bubble is actually the size of the average returns. That is what like this chart has to offer. Again, interesting visual, but yeah, the idea was just wanted to show you that these kind of charts can be prepared here. And the size is another aesthetic that I talked about, right? Size, color, fill, then the x and y axis, right? So those are the aesthetics that you would want to like and pretty much like play around with, like, I mean, and even the shape, right, are the things that you typically play around with. And as I said, the beauty of ggplot is you can overlay as many things as you want. Now, for example, in this chart, we actually overlaid a line. We did like a point on top of that. On top of that, we can add more things to it, and it is just like it just becomes extremely easy for you to add on more layers on top of things, as long as the readability is there on the chart. So let's look at like every stock and see what kind of distribution comes out. Yeah, so the continuously compounded returns for every stock across different years, how is it actually distributed? The reason why the data was shaped earlier, I'm pretty sure you're able to appreciate as to why it was done that way. Otherwise, it's very difficult for you to draw a chart like this. So this is almost like, I mean, taking every stock and like really understanding the distribution of the returns over distribution of monthly returns over a given year, right? That is what it is actually doing, and you're able to draw some inferences there. The good thing is, if you see the year, I think it is 2008. If you see, most of the candle bars here or the box plots are like pretty wide. That shows you like, I mean, there was like a lot of volatility within some of these stocks, and Verizon as a stock in general has been like more volatile than some of the other stocks that are out there, uh, except for this guy in couple of years, I think. But like, I mean, overall, the candle bars seem to be fairly wide here. So those are the kind of observations you can do on that. Maybe one final one, just to look at some other view of the data. Yeah, so this is again the data that is flipped across different securities for a given year. Kind of interesting. You can draw some summaries. You can quickly note that 2006 seemed to be it's not higher because I think we let the scales like, I mean, free. And if I were to just drop that for the time being, you know, delete it. Because typically we tend to assume that like this is all common and we tend to do an analysis around that. But in this case, it is not the case. For readability, we have increased it. If you see, like, it pretty much has been flat across all the years. With again this 2000, again Amazon being a fairly volatile stock. Even G in 2009 was pretty much all over the map in terms of the distribution of the returns. Okay, so time to draw some histograms. I think we draw some histograms in the previous session. We saw box plots. We saw how they can be organized into multiple panels, right? Or you're like, I mean, almost wrapping it by different facets or different variables just to see the distribution. Here, what we're doing is let's run it and then interpret the chart. So this is a histogram organized by every year across all the stocks, and then there are three lines here. The first line gives you an average, and the other two lines gives you like one standard deviation on either side of the average. That is what we have here. So we are using this vertical line rendering of ggplot to uh, to render those lines. The average is rendered as red, and the other two things as green, and the other two things as blue. Sorry, the other way around. Seems to have messed up the color, but like you get the idea in terms of what I'm trying to communicate. Okay, so an interesting way to look at like the data, like you can almost fundamentally, if you see, the returns are like fairly normally distributed, and that's why I had like mentioned earlier that returns have very good properties, and that's why if you see log returns or the continuously compounded returns are the ones that are used in a Black-Scholes pricing and few other models that typically tend to get used. That's with respect to the visualizations. As you can see, there are some interesting visuals there. You could add more like factors. You could add like the industry to the stock, right? You could add like multiple other things. You could create a portfolio of these stocks. You could play around like different weights and create like an efficient frontier. Those things are fairly complex. I'm pretty sure you will learn to do as you play around with the data and R. But I think you got the idea in terms of how to go about visualizing the data once you have massaged it and once you have understood what are the key dimensions on which you want to slice and dice the data. So core is a command which will give you correlations. The good thing is if you can just give an array of all prices or array of all or sorry a data frame of all numerics, it actually creates like a correlation matrix for you. So let's look at that. So if you see here, all the diagonals are all ones, so that means it's going against the same stock, and gives you every other covariance and correlation of every stock against every other stock. So you can draw some inferences there. One could potentially draw some kind of a heat map to understand what is the level of correlation. I'm pretty sure there are commands for doing that, and it will be a good exercise for you guys to explore that option. The other thing I tend to use often is typically you'll have 5 to 6 like important variables that you really want to visualize the data, and you want to visualize that in one shot, and just to get a quick view into how the data is distributed. So if you see this, this is an extremely powerful tool. I tend to use this a lot looking at the data. So if you see all the 9 stocks are lined up, and it's almost representing this correlation matrix, uh, but it is giving you a scatter plot, right, across every dimension. So it's very powerful for you to just get like a quick view into the data. For example, in some cases, you're not able to establish any meaningful linear relationship. For example, this one, you don't really. This is less linear than compared to the other guys. For example, this guy, GS compared to everything else, seems to be kind of all over the map. Maybe there is a reason for that because GS is in a different industry. Rest of the guys seem to be oriented towards like tech. It seems to be like the correlation or like the scatter plot doesn't seem to give any sort of linear hint at all, or the linear relationship is likely to be fairly weak in those cases. So you get the idea. You get like you're able to visualize this data set very crisply and make some interesting observations, like how we just did. Um, there's a package called as performance analysis, performance related metrics, which will help you and just confirm as to what that thing is. Performance analytics is the name of the package. That is meant for actually visualizing stock returns, visualizing. It's used by technical analysis people, and it has like some nicely customized um charts and box plots. And we could just like quickly Google it. There's a nice vignette as well for you to quickly refer to some of the things that you can do with this. So as you can see, there are like a lot of interesting things that are out there. I picked like few plots that could be useful. Um, so let's look at this box plot again. So this is a box plot of all the returns. The reason why we created that XTS object, because all these commands within the performance analytics package require like a time series object. Cumulative returns, again, we are looking at all prices XTS. If you are doing a diff, like that will give you and then you are dividing that by the lag, that will give you the return, right? That it's not an absolute return, but like it's not a log return, but it's actually a, a normal return calculation, which is like current price minus previous price divided by the current price, or the previous price will give you the rate of change of or like the rate of return. So drawing the cumulative returns, you'll easily see that Apple seems to have outperformed everybody, followed by Amazon. You can see that it's almost like you're constructing an index of sorts. Everybody is going to start from zero, or whatever is the number, and then eventually you're like, I mean, comparing everybody else with that. So it's like this $1. If you invest this $1, how much money are you likely to like make? If you had invested like $1 in February 2005, how much money are you likely to make here, right? So it's almost like 25 fold. It's $25 in 2015. So that such is the growth of the Apple stock. So yeah, so this actually completes this session. This is all I had for this session. Just wanted to give you a quick view into how to download the stocks, how to like maybe visualize the time series, how to compute like the differences, how to compute the compounded returns, how to do deeper analysis into the stock data, how to reshape the data frame to fit your needs so that you're able to do complicated analysis. And we saw some interesting visualizations on ggplot based on the prices that we had. So these are the typical things that you tend to do before you start like firming up your thoughts on what kind of model you want to create. Before you compute like, hey, these 20 different attributes that are likely to be predictors for certain things that you're trying to do, you would like to visualize like, I mean, the data set this way for you to get a good insight into how the data is organized. So that's all we had. The next session we're going to cover how to create test data, which I'm going to focus slightly more on that, because that is likely to give us flexibility in terms of creating data and apply our business knowledge and have these data sets ready so that we can use it for different purposes. Thank you so much for attending.